Welcome to episode 10 of Unlayered. After a brief hiatus for July 4th, we are back with an amazing slew of guests, starting today with Kevin. Kevin's been a big fan of the podcast and a close friend of ours we've been talking on and off with for months now about this topic at hand, which is blockchain basics. And by way of introduction, Kevin is a former embedded engineer at Apple with a focus on signal processing, and he worked specifically on the AirPods team, former Solana Labs core engineer. And during that process, actually discovered his passion for developer relations and has recently transitioned over to a role as a developer relations engineer at Modular Labs. So super exciting. And obviously he has a very interesting background across multiple blockchain ecosystems, which is why I think kind of the perfect guest for today's discussion. Kevin, why don't you tell us about your thoughts on blockchain basics and why you think this convo is so important to have?
Yeah, so just to give some background, we've been chatting about this for months. I think, me, Sal, and Dave kind of came together actually over this conversation. I was fed up with simplistic explanations of blockchains, this blockchain trilemma. While it's a good abstraction, it was kind of presented for a very specific scaling trade-off, right? It was Vitalik discussing sharding, right? And it's been uniformly applied to every construction of blockchain since, as if it's as legitimate as cap theorem, which has actual math and theory behind it and peer review, And so I have found that that's actually hindering kind of adoption and the view of blockchains. And that's, working in alternative ecosystems, that's become, pretty frustrating because essentially there's this predominant view out there, engineering is really simple. And that if you don't build this one way, then it's wrong. And I think when you're a practicing engineer, you realize everything is just a series of trade-offs, and not giving, airtime and light to the actual things that make up those trade-offs is actually hindering the understanding of what blockchains could be or are currently.
I guess a thing that I've noticed is it seems like anything that doesn't come out of the kind of Ethereum academia side in terms of blockchain architecture and how to scale long-term is almost disregarded as not valid. Have you noticed that? And obviously I don't think you have that view. There's many more approaches that I think could be feasible as well.
Yeah. So I think this comes kind of down to the difference between research and actual practical development. And what you find is there's research leaning institutions that, if something isn't, peer reviewed, it is kind of viewed as invalid. And then there's another school of thought that's move fast, build prototypes, prove it works. I think both these things have, merits. At a certain point, research can go on forever. It's an open question. And engineering is all about taking research and putting it into practice. And so there's definitely this, dichotomy between the two views of the world. And I think both have value. I think Solana leans very heavily on the don't do research, prototype, game it out. The research is actually modeling it out, building a prototype and seeing if it works. Whereas I think Ethereum leans very heavily on the just do the research, do the peer reviews, make sure everything's really solid. I think practically, being a startup, you need to be somewhere in between, right? And so I just think most things in blockchains aren't black and white, and it's worth bringing light to the fact that everything is a series of trade-offs at the end of the day.
Do you not believe that actually there are other factors to include within that? It's not just the case that it's only security, decentralization.
Okay, security, right? That is a very arbitrary term. Security in what? How easy it is to hack the chain? Economic security, which there's an argument that that's not even real because you can just steal stake from a remote code execution attack, essentially get people to run the wrong code on their validators and just steal all their stake. That's practically the easiest way. And so it's not really oh, you have to acquire it all in the open market. And so this question of, security, it becomes a lot more nuanced than just saying, oh, there's a lot of economic value on the chain. That doesn't actually capture the real attack vector. with decentralization, it's like, okay, are you talking about Nakamoto coefficients, like geographic distribution? There's like so many things that go into that. How many full copies of the state are there? How many full nodes are there? How easy it is to run a light client? How easy is verifiability? And I think like just saying decentralization and looking at a single metric is really like reductionist. There's also like, finalization times come into that, and that has play into like security as well as decentralization. You know what I mean? How fast it is to sync and get consistency across a bunch of nodes. How fast do you have guarantees that what the chain tells you was confirmed is actually confirmed, like finalized? And then, yeah, there's like scalability is, what does that mean? Like practically like TPS, but like what if your transactions are bigger? Then like inherently you're going to have less TPS because they're bigger. And so like you need a metric, something like throughput, where it actually has like bytes per second, right? Something that's kind of uniform. And so I think like the blockchain trilemma is a very like subjective kind of not really quantifiable thing, and a lot of people like equate that to cap theorem because it's somewhat similar, but whereas cap theorem has like very hard to find like definitions and is peer reviewed and like understand throughout the industry, I think like a lot of the blockchain trilemma terms just like it's not clear how we measure these things. And especially in a world of L2s where you're like modularizing everything, these trade-offs become like a lot more complex to reason about.
It seems like there's a lack of rigor, especially when it comes to this trilemma that keeps popping up anytime people try to compare blockchains. So maybe on that point, actually, how can we think about blockchains from maybe first principles?
You can think about it as like a distributed database. So database is just like a series of independent servers with some memory and like essentially instructions of code to run on them. And so there's hundreds of these. This is what we call full nodes, right? Or thousands if you're a bigger chain. And essentially they're all like essentially like a ledger database. And so they track pieces of information that you send to them as transactions. You can think of these as just like line items of, in whatever coding language telling it like what to do. And then essentially this database on all these replicated computers goes ahead and like executes those instructions. Now, kind of the fundamental like thing of like why it's a blockchain is because these blocks, this kind of like this database that's getting updated is replicated on every machine. And that's extremely important. In, traditional distributed systems, there's something called like availability, which is just like how guaranteed are you if you hit a node to like get something back. In a lot of these systems, like not every node stores every piece of information. And so like they'll maybe like ping another node to get it. In blockchains, it's actually really important that every node has like the canonical state, essentially like the same view of the world. Another thing is that because it has this like replicated state, it inherits this like, it doesn't necessarily inherit, but the way that they're designed and the principle that makes them blockchains is immutable history. And so like this state, as it progresses, you have some sort of ledger database, right? About like what were the things and the essentially like data that went into that state transition function to bring it to the new state. And so typically validators only hold in memory like the current state, but then they have some amount of history. And this is actually dependent on chain. We can get into this a little more as we go down the rabbit hole here. How much history they actually store. Like Bitcoin stores it all. That's fundamentally their principle.
The next question is, why do we need this type of thing? Why do we need blockchains?
The easiest way to put it, now this is like hard for a typical person to understand, but it hits the problem nail on the head, is like it solves the double spend problem. And that's like the Byzantine generals problem. But like, okay, what is that? Like if you're not going to go read a textbook, like what actually is that? It essentially like guarantees that you have like a shared state of the world on every machine, which means there's like a objectiveness about the truth of the world, right? Because the ultimate goal is to be able to take a single copy and have assurances that what's on that single copy is the same thing on every other copy. And so like essentially the double spend problem is like, how can I guarantee if 3 people are in a room, when I talk to one person, if I tell that same information to the other person, that I haven't told them 2 different things, And so I can't tell you I spent $5 and tell someone else they spent $10, right, and pocket the difference. And so like that consistency problem is essentially like part of what blockchains solve. Another like very useful fact that falls out of this is like in order to have consistency, you end up having shared state. You know, like Web 1, right? We had protocols on the internet, and it's just like TCP, whatever. Like if you followed the rules, you were able to join. There's no policies, right? If you follow these protocols, you get this access. And so like when you have this shared state, it essentially turns the fabric of the internet into this like framework of arbitrary programs that people can just call. What this means for app developers is like you're not subject to a distribution channel, like besides the blockchain itself. Like if you want to launch an app, you launch an app. You know, if a protocol wants to support apps on a chain, they support the chain. They don't support your app, right? And so it removes this like kind of segmented property that we ended up kind of falling out of Web 2 from Web 1, right? People wanted to build businesses. What's the typical way to build businesses? Like fundamentally, blockchains are social coordination technology, right? And so Web 2 was like, okay, now we can like not just like read, we can read write, right? It was like, okay, we have this like communication channel. And like I bet you've heard this before, is like, you know, Web 3 is read, write, own, right? But inherent in that own function, like means that there's like a neutral arbiter saying like who owns what. And that neutral arbiter ends up being this like shared state, because you have guarantees that it's the same on every machine. You also have guarantees that you don't have to trust a single one of them. And it ends up being kind of like the Lord of the Rings thing, where it's like the ring is too powerful. So like, what do? We throw it into Mordor and let the power distribute, right? And like fundamentally, this like poses issues for the way that we've traditionally like monetized in Web 2, because I think like Web 2 was a lot about like splitting up, you know, these segments on these neutral layers in order to create like cost centers and profit centers to like solve problems. And Web 3 is like throwing that up in the air and saying, okay, wait, actually, like we can do these same things by just coming up with common sets of rules that everyone follows. The problem is, and I think like a big problem with adoption of blockchains for like, you know, Web 2 companies is that's antithesis to their business models. They like make the money by the walled gardens. Like Apple doesn't want to open up its ecosystem. When you buy an iPhone, you buy AirPods, you buy a Mac, because they all work together. And so blockchain's like, what if we could do that for all technology? You know? And so an Apple or a Google is going, wait, but then we have to work with all these other people. But it's odd because there's this dichotomy of like, okay, well, people are building on blockchains, and they, as long as enough people join that blockchain, they don't have those same issues, right? And so everyone building on a blockchain gets the same distribution like you would have gotten in Web 1. And so like there's kind of this dichotomy of like, how do you move Web 2 onto Web 3? And while I think that problem has been a little bit hard to get product market fit recently, like just with the advent of AI and what we've been seeing, I think it like literally forces the issue. Like there's like, you need to be able to know if something's human or not. You need to have some level of data sovereignty to say like, AI, please don't eat this. Like it's mine. And when Web 2 businesses start realizing this, I think they're going to see the necessity of blockchains, because whereas on like a Google, right, they make a lot of money from their ads. And well, where do you see ads? When you're browsing, you know, you're going through different sites, you're doing a Google search, you're trying to find the right information. And as you're doing that, it's like contextually popping up ads for you. In a world of AI where you can just ask a question and it spits you back an answer, like Google doesn't have this distribution channel anymore. Like their profit centers are already like disrupted, right? And Web 3 and blockchains kind of provide this like new neutral fabric that they could plug into to actually like identify what's human, what's AI, like, you know, serve content and stuff like that. Essentially like segmenting data in a way that can be accessed. And I think like this problem is still a little bit years away from being solved, because fundamentally like the internet doesn't understand blockchains like in its native TCP fabric. Like blockchains have their own protocol, the internet have its own protocol, but there's not like a browser that just like is a blockchain, right? Where like when you're like pulling down browser code and like live rendering it, like it actually like understands this is coming from blockchain, and therefore there's certain restrictions about who can access it.
I think just to put a pin on the point that you're making sort of time and time again here, the difference and really the breakthrough, I think, of Bitcoin and of solving this double spend problem was being able to have a distributed, decentralized system, because when everything is decentralized and you have loads of different nodes and certainly in a permissionless state, suddenly you can have that neutral, censorship resistant substrate really to all of these things that you're talking about. I always struggled slightly to contextualize the double spend problem, but I think prior to Bitcoin, there were attempts at doing digital money, but they were centralized because if it's centralized, then you can we can have one person who just decides what the ledger is and make sure that no one's double spending the money. But as soon as you try and open that up, and obviously those attempts didn't really work because I think the governments were just shutting down these centralized options. So I think Satoshi knew you have to decentralize it. You have to open it up to have this neutral substrate, as you say. And he was the one who sort of solved that double spend problem, because suddenly as soon as you have more actors who are maintaining the same ledger, suddenly you have that issue of maybe different people are recording different transactions. And that's how, unfortunately, you can have slip ups basically go through, and suddenly you can get a double spend go through. So I think that's the crucial blocker really to having decentralized systems was this double spend problem, and that's sort of what Bitcoin did, and that's just unleashed really this world of decentralization, neutrality, censorship resistance. Is that about right?
Yeah, I mean, I think you guys just talked to Josh Rosenthal, and the very first, you can almost think of it as the very first blockchain was double entry bookkeeping. It's like, but that's between two trusted parties, right? So they know the other guy has the same thing in their ledger. And when you get into that on N parties, the most obvious application of fixing the double spend problem is money, right? So it's very intuitive that the first application for blockchains would have been Bitcoin, right? It falls out from that problem, just fundamentally. Now I think the reason centralized ones failed before is because a nation state's two main powers are the power of violence and the power of the purse. And so fundamentally you're saying, hey, nation state, we don't want you to have power of the purse, right? You do that in any centralized entity, the government's going to crush you. And that's where censorship resistance comes in very importantly. And it's kind of the same model for Web 2 companies, right? They're not going to move on the blockchains if you're saying fundamentally we're taking away your power, right? And so you need to provide another value prop beyond that. You can't disrupt Web 2 and give them new value props if the only thing you're doing is taking their profit centers away. You actually have to also solve problems. And all of Web 2 was about scaling it to solve those problems. So I think that's kind of where we're at, in the blockchain system. It's okay, money, it makes a lot of sense. Bitcoin, solves store of value. It's decentralized. It's probably good enough for a while. I think the Ethereum case is an internet bond is pretty strong. It's probably good enough for a while, but at some point it's okay, we need to move past monetary use cases. This problem is a fundamental computer science problem, and it can be applied to a lot more things. And it's kind of just showing, hey, how we build these systems are going to solve these problems in different ways that can actually add value rather than just taking away actual profit centers for these businesses.
Basically, Web 1 was just the original version of the internet, and what made it powerful was that no one controlled it. As you said, TCP was basically the only protocol you interacted with, and as long as you knew how to do it, you could put your content on there and anyone could read it. And then Web 2, with this idea of read plus write, it brought down the barriers to entry for regular people to contribute content for others to read. But what it birthed was these control vectors in the form of companies like Facebook and these social networks and even search engines too, where the price we pay for content aggregation and curation on behalf of consumers was that they got to decide who does what or who sees what and when. Now, the reason why blockchains are so interesting, as you alluded to earlier, is that it's the same ethos as Web 1, where it's bringing things back to this community-owned, permissionless world, where it's not just about users owning assets. It's theoretically no one owns the network And at the same time, everybody owns some of these dApps based on how they're architected. And so we can marry a lot of these principles from Web 2 and Web 1 to create, in our view and a lot of other people's view, a better internet that's more composable and more permissionless while still retaining a lot of those benefits that we talked about.
This is where you have to get into discussions of like how blockchains are built and what decisions these blockchains are making. Because, as we've seen, like, permissionless blockchains, they're somewhat successful, but it's not like massive money is moving on chain yet, right? And when you talk to these companies, what you find is like they're a little hesitant of going like fully permissionless, and while that's what the people want, like something needs to force that issue. And like, I think with the advent of AI, we're going to see that very quickly. But beyond that, like there are actual like new value propositions you can make. It's more of like, how do we overcome those network effects and prove to Web 2 that those value propositions like are big enough for them to like change their existing business models. And the promise of blockchains is that you can do that, right? Like you're not gatekept from running that experiment. Like because we all have this control, like, and because it's distributed, like we have the ability to like literally say with like just the knit and grit of developers, like we are going to prove it to you that we can build something better, right? And I think the kind of the soul searching of crypto right now is like we're finally getting to scalable enough systems where we can say like, hey, this is an actual value prop beyond just like me owning my stuff.
I think one of the other core proponents of blockchains is their ability to get the flywheel going, because you're sort of distributing, the power and the value of that network to the crowd, if you like. I mean, Bitcoin, digital money wouldn't really have got off the ground if you couldn't get the common man basically to participate in the network and gain a reward from that network. So just when you're talking about how can we overcome the network effects and also looking at sort of the Web 2, this re-centralization of the Web 2 and these huge network effects that they've built up, it really does feel that you need these sort of distributed systems to have any chance really of breaking that oligopoly.
Yeah, and I think you hit on something that's like quite important. These blockchains, like beyond just being like distributed ledger databases, like they have this kind of soft property of like crypto economics. And what you see is that like the most successful crypto apps or the use cases that make people go, oh, that's a good idea, are the ones that like actually leverage the soft squishy social side of blockchains, and so things like Helium, where it's like, oh, like you're solving that last mile problem fundamentally. Like 5G towers have a tenth of the range as 4G towers, and how much investment cost does it cost for like all these centralized entities to go and put up all these towers? You've solved this like, oh, I like have a profit motive to then go like put up a 5G tower to cover, that last mile and partner with a bigger player and have like a profit sharing incentive there. And so you're essentially like able to like bootstrap these network effects, but you're not just bootstrapping them because, oh, it's shared state. Oh, it's like that soft squishy like thing that the property of solving double spend solves, right? That economic problem, that coordination problem. And I think like a lot of people building in Web 2 tend to forget that like that is actually one of the main value props. They go to interoperability, they go to composability, they go to like neutral parties. But the other like kind of special superpower is this like social coordination aspect and the ability to like bootstrap those network effects on your own.
Because again, it started with Bitcoin and it basically said, follow the rules and you'll get money, you'll get a share of the network, and hopefully it's going to go up in value. Don't follow the rules, and we'll start, certainly on Ethereum, we'll start taking your money away. Basically, you put money up and we'll start taking it away. So it's that sort of socio-economic drivers, really, the game theory of blockchains, which, as you say, is it sort of it fits the human side of blockchains. That's what you need to make them work, because the rules have to be followed by humans just as they are by the software effectively. And so you need these sort of game theoretic principles in place to make sure that the humans also behave correctly, just as the software does.
Yeah, there's like that incentive angle, right? It's like not just coordination, but you have to like incentivize that coordination. And so I think like a lot of people get pulled down like incentives in like a speculative form, into this like, oh, we can make number go up, But I think these incentives are actually like much more fundamental and much more kind of the fabric of what makes a blockchain powerful. And the more apps and use cases that can think about those in non just monetary terms are really going to be the major unlocks. It's like, how do we use this superpower of coordination within an application? Going beyond just value transfer, like literally solving like coordination problems such as like the last mile problem with distribution, or even, like payments, right? Like it's hard. It's like almost one of the most obvious applications of blockchains is just like payment rails being better. And it's like, okay, like why isn't there any adoption, right? It's because there's no incentive to adopt a new payment system right now. And like beyond that, it's just like there's scale and cost involved. And so like I think the person that can like crack that nut is gonna like, that's where you get like these really like interesting use cases like DeepIn and stuff like that.
With these key primitives in mind, so we have this new super powered database that's called a blockchain. Now, I guess the question is, why should we care about anything that's not Ethereum? Didn't they figure it out already? Most people are using it. They have the ICE-TVL, so on and so forth, all these kind of metrics people throw out there. Why should we care about alternative designs to blockchains?
Yeah, and so I think this goes back to like the like trade-offs thing. It's like Ethereum has made a very opinionated and very specific set of trade-offs for what that community finds valuable. And not considering other designs is essentially saying that no other like ideological definition of that is valid, which is almost fundamentally against decentralization, right? Like if you want something to be decentralized and distributed, then you should want there to be other constructions, and other avenues of exploration into seeing what's best. Like fundamentally, like blockchains are made up of three main things. There's data availability, consensus, and execution. And so just to quickly give a summary of what each one of those are, and then we can dive deeper into each one. The data availability is saying like, okay, if I ask the network for this data, like what's the guarantee I'm going to get it back, and how fast am I going to get it back? There are metrics that you can measure those properties by, and we can go into what those are. But essentially like the data availability problem is all about like, okay, now that I have this history in this immutable store, like when I need to use it in my app or do something, how fast can I get it? How fast can I verify it? Yada, yada. Then there's this like consensus problem. This is like the other arm that blockchains kind of need to deal with. And this is like in cap theorem, it's actually like it's guaranteeing consistency. So it's saying that like if I ask one node a question, it doesn't matter which node I ask because they're all going to have the same information. And so I'm guaranteed to get a consistent answer back, right? And so the job of consensus is essentially to make sure that every full node has that same view of the world. Like at some point, it's this problem of like, how do we come to agreement on it? And then we have execution. Execution is the thing you hear most people talk about because it's kind of the easiest to innovate on. And you can just think of that as like the operating system, like, Mac OS versus Windows. And we might have like different computer developers. You might have like Apple who uses Mac OS, but then you also have like HP and Dell that use Windows, right? And so you can almost think of Solana and the SVM as like Apple Mac, right? And then like, all these other chains that are EVM chains as like different computer manufacturers, but fundamentally they're all using Windows. And so, yeah, consensus is kind of the easiest thing to innovate on because there's a lot of body of knowledge about like, okay, how can we change this to make it faster? How can we do these things? But because it's a blockchain, you can't think about it like a traditional computer. Like there are trade-offs that happen because of the other two parts that we talked about, consensus and data availability.
There's ways to, because I'm not even familiar with this, there's ways to kind of quantify like one blockchain's, and people abbreviate it to DA oftentimes, but one blockchain's data availability versus another. Like, yeah, how do you think about that? How do you compare? And maybe let's double click on that developer experience too.
So I think there's like two kind of maybe flavors of the data availability like characterization. I think one of them is like much older. This is like the BTC versus AE thing. It's like how much of the history should a single node store, right? If this thing is going to run to infinity, like there is some point at which like the memory of a node is just like expensive because there's a lot of history and it's been running for a long time. And so this was kind of like the small block, big block wars in Ethereum versus Bitcoin, right? And like Bitcoin was like, oh, you know, like Ethereum is invalid because like you can't sync from Genesis without an archive node, right? And like in the Bitcoin world, like it's very important to be able to like start from the beginning and run all the way to the end and everything be there, like every transaction, every historical state change and all of that. Ethereum and like modern day blockchains, like high throughput blockchains, the reality is that like at some point the data, like the state growth is just too big. Okay. And so you have to kind of like look at it as almost like a proof by induction. And so how that works is like you essentially have a base case that you assume is true. Okay. And you have a set of rules that you assume is always correct. And if you move through that set of rules from your base case, you'll get a new state. And you have a guarantee about that new state being correct because the thing you started from was correct and you believe that the steps to get to the next thing was correct, right? And so if you can say that if you can prove like mathematically that the correct things happened when I moved from state 0 to state 1, by induction is what it's called, you can prove that every state transition after that is also correct. And so using that principle, you arrive at a point where, okay, I can actually just store like some amount of historical state, but then checkpoint that with, you know, cryptographically secured, you know, either ZK or state roots or like Merkle trees and stuff about like, you know, hashes about things that happened before. And then when someone wants to come back to me from long, long ago and say, is this valid? They actually have the job of finding that data somewhere. You know, like there are lots of teams like dedicated to kind of solving this problem, like Filecoin, Arweave, just like the Graph does a lot of this. Essentially, RPCs do a lot of this. Essentially, like taking everything past like a predefined, what most blockchains call an epoch worth of data, and essentially like providing that against the little bit of data that's actually on the chain to say this is valid from there to there. Now, archive nodes and full nodes, like the idea is that you have all that state, but as these chains start to scale to infinity and these becomes like, you know, years and years in running, there becomes a point where like you just have to trust, you know, 10 years ago, if we believed Ethereum was valid, that it's valid today if I run 10 years of history, even though maybe I don't know what happened 11 years ago, right? And this is just kind of the reality of state growth, right?
So are you saying that, especially with these highly performant blockchains, that there will be a point, or maybe there currently is a point, where you just can't look into the history of transactions on that blockchain?
Yeah, it's more of like, you could. There's probably like a couple of actual providers that are, you know, like holding it, like Filecoin. Like I know Solana right now is in the process of moving everything, the entire historical state to Filecoin, which is kind of like a distributed history, you know, like solution for like the very old state. But Solana nodes only store like an epoch in the node. So that's like an epoch is like 2.5 days on Solana. And then they also hold, I mean, you have to hold, what you can't get around is holding the state of every account, right? Like you have to know the current state of everyone's balance, but all those transactions that made it go from the next one to the next, like that you only need to hold like maybe an epoch, and then the rest gets pushed off to RPCs, other data warehousing solutions. There are like entire blockchains dedicated to solving this problem, like Genesis Go on Solana, Arweave, you know, Filecoin. This is just like a reality of what high throughput chains are going to have to deal with. And so like what that ends up being is like, it's kind of like what Web 2 people do is like, if you're building an app and you care about the app, the data relevant to that app, then you should have an RPC storing the historical state relevant to that app, right? And so you can always verify that state's correct against the blockchain, but when you want to serve it up and do things quickly, you have it locally and you can do that.
Kind of to add some more numbers to this, because you mentioned Solana nodes storing like all the current account states and about an epoch of data. That quantifies into what, like tens or hundreds of gigabytes of data on the actual machine, like individual machine, versus Ethereum, which might be single digit gigabytes. Is that like a decent kind of approximation for scale of size of data?
The actual history data is what's expensive, right? And so you're still probably in like the couple of gigs on Ethereum, but it is like much lower because essentially they're producing new data every 12 seconds on Ethereum, and Solana it's every 400 milliseconds. And so there's just like a lot more data there.
I guess I don't immediately see a problem with just trusting archive nodes, but is the issue that because it gets more and more expensive, especially for these high throughput chains like Solana, to store all of that history, that that in and of itself is a centralizing vector? Is that the main criticism, or are there other criticisms here?
Yeah, it's like the people who are willing to bear the cost of storing like petabytes of data is going to be relatively limited, right? A better solution is to put it on a blockchain that's literally designed for this, right? Like Filecoin or Arweave or Genesis Go, like a solution that's like literally thinking about, if you have petabytes of data, how do we distribute this around a bunch of other nodes so that you can call it up and get it back. And Solana, like fundamentally, I think it's more designed as like, no, we want it, like the current state is like real-time censorship resistance, essentially. It's like you can maybe like not have the history right away for very old things, but in the real time, like in financial markets or stuff, when you need that, it's there, it's available, it's quick, it's fast. And then there's like decisions about how long we want that to stick around. And I mean, this is even a problem with rollups, because like Ethereum can't store all this data. It's very expensive. If you look at EIP 4844, like they literally are implementing blob transactions that Ethereum's only going to store for a month, right? And then all that history on the L2 is gone. Like unless the L2 has a data warehousing person to store it, like it's gone. And so like, all these chains, when you get up into the point of where you're having a lot of data, a lot of transactions, have to make decisions around what to do with this. And like they have like very deep implications. They tell you like on an L2 you can always escape, right? Well, in order to escape, like the chain only holds the state root. It doesn't hold all the historical transactions. So if, say, you're in a DeFi position, you now have to say, here's the state root that I came from. Here's all the history of the transactions that got me here. Include that Ethereum. Well, Ethereum can't do that unless you can provide that like difference from the state root to where you're at currently. And if that difference expires in a month, you can imagine a situation where you're, in a DeFi protocol for a long time, your state's gone, your historical state's gone, no one warehoused it. How do you exit? You can't prove to Ethereum that it's time to exit anymore. And Ethereum researchers are thinking about this. Like, this is a very solvable problem. Like, don't get me wrong, but it's a much more complex, like, thought process than is currently marketed, right?
So you're saying, okay, so you're on a layer 2, the sequencer, at the moment they're centralized sequencers, maybe that's gone down, and there are these escape hatches basically where you can still send your transaction from the layer 2 over to the Ethereum layer 1. So that's why people say you can inherit security of the Ether1, even if you're using the layer 2s basically, because you can always escape there. And you're saying that there's this problem, and I'd just like to try and put a pin on why that problem would exist, that there's a problem where you can't just say this is my current balance, which would be the sort of the current state. There's also the sort of historical bits and pieces which may not be immediately available, or may have just been deleted. And so why would you need those historical balances?
Because you have to prove to Ethereum that how you got to your current state is valid. Like, you followed the rules of Ethereum. And so if it's not in the state root immediately, like Ethereum has to be like, oh, it's a little different than what my view of the world is. Like, you have to prove to me that all these things happened before I'm going to let you roll that back, or come onto like Ethereum L1, right? And that's like, okay, like you better have your call data ready, and you can definitely like build solutions around this. It's not an unsolvable problem, but it's definitely like hidden under the hood, right? It's one thing if you're just an account on an L2, like if you're just holding ETH on an L2, like there's nothing to unwind. Like you can submit, like transfer back to the one. But if L1 is not for users and all DeFi activity is moving to L2, you have to assume most of these coins are not just sitting in wallets. They're in staking contracts, they're in DeFi being active, they're being traded against, right? And so when this event happens, there's two main problems. Essentially, like one, you have to get the data in order to prove to Ethereum, but also there's like a time element in DeFi, right? And as much as like a centralized sequencer going down, like if no one can move any money, that's fine, because like no one can essentially liquidate you. The chain is down, right? The problem is the price of those assets is not static because price is not an on-chain thing. Price is trading on centralized exchanges. It's trading on, other roll-ups. It's, oracles are telling the chain like what the price is, and oracles are basically like anything that's not on chain. Like, how do I get information about it? Right. Price is a very like price of what, like in dollars. And, it's like a very human soft like thing. It's not actually defined on a blockchain. Right. So, when like a centralized sequencer goes down, if you're in a DeFi position, and then and we've seen this happen on Solana, Solana goes down, people get bearish on Solana, start dumping it on centralized exchanges, nothing on chain's being liquidated, but the price is moving. As soon as the chain comes up, this liquidation engine goes, oh, price is down here, bam, you're done. Right. And so that's the risk. As much as you can say, oh, I can exit to an L1. Yeah, you can exit to an L1 if you're doing nothing but holding it on the L2. You have all your call data and like you're ready to go the immediate this happens. But that's not things people are thinking about. They're saying, oh, I'm safe on the L2. Like, let me go get into all these positions, right? Okay, so the other problem with data availability is bandwidth, right? And so to go back to the data availability question, and then we can go into like consensus, because that kind of is the other shape of this problem is finality. It's like, when do you know things are actually consistent? The same problem with the L2 exit, right? It's like, you need that historical state at some point, and how much of that historical state is on chain is actually like a bandwidth problem, right? Like how much can be served up at one time. Then we get into like kind of scalability issues, right? And I think like data availability is one of the main bottlenecks for performance, because at the end of the day, like what is a chain doing? It's writing bytes somewhere, okay? And how fast it can do that and how much it can do that at once is actually like a very fundamental like, well, your TPS can't go above that because it's just simply like there's not enough network bandwidth to like support it, right? And so the other kind of shape is, we were talking about these two shapes of the data availability problem. There's the historical state problem, right? But there's also the just like, how much data can I send to you and how much can I get back at a given time, right? And this has like a lot of implications for, like the more bandwidth, like fundamentally, like when you're going to a cloud provider or even just a bare metal machine or even just running at your home, like if you want more bandwidth, if you want a 10 gigabit connection, from whatever your ISP provider is, right? It's going to cost more than, a 1 gigabit connection, right? And so like scalability, right, is limited by bandwidth, which has a cost. Okay. And those costs, like fundamentally, like blockchains have to make a decision. Like they can't get around this. Where do we want to put those costs? Okay. And this is like, it's philosophical. There's no like real actual, like, this is the right way to do it answer. I think Solana has landed in this camp of like, we believe the validators, the people running the network, should bear the cost so that the users and the businesses built on top of the network don't have to. Okay. Ethereum is in the extreme opposite direction, saying, the validators should be the ones making the money and the users and the apps should bear the cost. Like, is one better than the other? Like, ultimately, this is a sliding scale, right? And where you slide that actually has like implications on cost of the node because of bandwidth requirements, right? And so, yeah, I think like this gets very pedantic in a lot of circles about like, oh, you have big nodes, like therefore it's bad. It's like, well, like you can't scale without them, like, and so like who bears that cost? It's really like more of a fundamental like a philosophical decision. I think and this is kind of getting in a little bit to like consensus, but like, you know, it's like, how expensive is it to verify the chain, like to make sure that like something is correct? And I think like the majority of blockchains are converging on this idea that like it's okay if, you know, the full state and like the full building of things are a little more expensive, as long as me as a user, I can verify that that's correct cheaply. And this is where things like light clients come into play. And I think when you look at these, you know, ecosystems, what you realize is like everyone faces this. There's no way around it. And it's just a matter of like where you're setting this cost scale. And then can we offset that to get the trust properties we want via light clients and other solutions?
Why don't we kind of change gears and talk a bit about consensus and kind of how that's that next key property here about blockchain design?
Yeah. So there's like, you know, data availability is kind of that fundamental, like how much like raw bytes can I get through? Like the actual wire that's running from my house to yours, you know? Whereas consensus is then like the layer right above that. Okay. It's like, now that we have, you know, this much total space, like how fast can we agree on what happened? Okay. And how fast can we give guarantees that everyone on the chain has the same view of the world? Or even are we going to give guarantees that everyone on the chain has the view of the same of the world? I think Solana is very opinionated in the fact that like, you know, every full node is synced at the speed of light around, you know, the world. Things like Avalanche with subnets, like a subset of their network has a view of the world. Like sharding, that's literally what sharding is. It's taking this opinionated stance that, oh, not every node needs to know everything, but they all need to be verifiable if they ask each other. This has like implications for UX, right? About like who you can ping where, and then it gets into like bridging problems and stuff. So like, yeah, there's definitely implications, but this is the shape of the problem, right? And so like consensus is right, the set of rules that nodes follow in order to like eventually agree on something. And that like the kind of the shape of the parameter that you're looking at there is like, what is eventually? What does that mean? Right? And you hear like a lot of buzzwords like finality and slot times, right? And finality is basically saying like, when do we have a guarantee that 67%, like the majority of the network, I think 50% in proof of work, right? Like will say that this is correct every time you ask them. Okay. And how fast does that happen? So like there's kind of multiple flavors of this. I'll go into them a little bit, and then maybe if you got some questions. There's like deterministic finality and probabilistic finality. Like in proof of work, there's never a point where like you can say like this is final, this is 100% final, there's no probability that this will ever be rolled back. In proof of stake, it is like that, and this is like just the way the consensus algorithms work. In probabilistic finality, you're making the assumption that the network incentives are so high to overcome past a certain point, the probability of it ever changing is almost infinitesimally zero. And so like on Bitcoin, that's saying like the amount of hash power you would have to have in order to rebuild the chain to propose a longer one is beyond what normal computers can do today. And therefore you have like some probabilistic guarantee that no one can propose a longer chain and essentially like change the history. And actually Solana works on this principle a little bit too with proof of history. It's essentially saying, you know, it's actually proof of work with time is what proof of history is. Now it's hybrid in Solana in that like actual consensus is proof of stake, but they do make this assumption that if you're, you know, if from a certain point, it's like this probabilistic finality as Solana is like working through this like proof of history thing. At a certain point, it gets like locked in and that's it, no matter what. But you can imagine being like a quantum computer, a very fast computer, like at the last state root. And then you just like calculate a bunch of stuff way faster than any other computer could and propose it, and Solana accepts it. The cool thing with like deterministic finality is you limit the damage that could be, you know? And so like on ETH now, and ETH is kind of a hybrid. It actually like in times of, and we can go into this like safety versus liveness, this is kind of the other property of consensus. In times of like slowness, it falls back to like probabilistic finality because it used to be proof of work. And then when it's operating normally, it's actually is like proof of stake, and there's like a point at which you can say like, no, this will never be rolled back. And so it's like in Solana, it's 32 slots, right? So once like a slot is 32 passed, you're guaranteed like this is how it is.
A slot's 400 milliseconds, right? So that's about
almost 12 and a half seconds. It's almost the same as Ethereum. Now, the cool thing with Solana is you get like optimistic finality, which is honestly like, it's hard to say it's any really different than rollups, right? Getting soft finality, right? Except that like rollups do it by like literally having another consensus mechanism if they're gonna do this, if you're gonna decentralize a sequencer, like you essentially have to build a construction to give that like, oh, this is what's gonna get committed within like some amount of security guarantees. And like in Solana, it's essentially saying that like your honest majority security guarantees, in those 32 slots. But when that majority decides that, hey, we've all seen this block, you can have like a soft confirmation that it's not going to just suddenly reorg because of the way like the towers are built in Solana. Like it's kind of like a sliding window as it's like building this consensus tower. And essentially like at a certain point when you get 67%, like the majority of the network is not going to switch to another fork. And so you get this, essentially a lot of people use, that's why like Solana is considered fast, is because like when you're bridging, they're like, no, we have to wait for 32 slots because you're taking value off this chain. We want the strongest guarantees that this is never going to be rolled back. But in like normal apps, like, optimistic finality, or I think it's called like confirmed, not finalized in Solana, means like, okay, 67% of a network is committed to this fork. And so the likelihood of them moving to a different fork is very small at that point.
Because I was wondering for payments, because I thought, if you have to wait for the finality, the 12 and a half seconds, maybe that's going to be too long for using Solana as a payments rail. But do you think that they would actually probably revert to the optimistic finality, which is when, as you said, over 66% of validators have agreed?
I think, mostly they can rely on confirm, because like 32 slots in slot, 12 seconds, that's not a lot of, like, especially in a payment application, there's not a lot that can go wrong in 12 seconds. Now, trading venues, like market makers, this actually becomes a problem. And if you talk to people, even, Solana is supposed to be designed, as a trading firm, but if, in order to hedge the fact that, like, maybe when I say this is, a trade, it gets rolled back, they end up having to quote wider to like adjust for that risk, or just spam transactions to like kind of hedge the fact that things might be moving against them within that time window. And so that's kind of where we get into this discussion of like chains that are doing single slot finality, essentially some guarantee that like within the first round, like you have a guarantee it's going to land in that order, even if it hasn't come to consensus yet.
No, I think that's a very valid point. It's one of the main criticisms I've heard about Solana that perhaps is valid, is that this time to finality might be too long for some use cases. I'm less familiar with blockchains that have single slot finality. Are there any examples, and how do they accomplish that?
There's essentially this new like algorithm everyone's kind of like clamoring over called like hot stuff. It's like a modified Tendermint. So the way Tendermint works is like every node in the network like first agrees on what the order of the block is going to be, and then they agree that that's a valid block. They all execute it and say like, okay, this gets added to the blockchain. But by separating those two steps, what ends up happening is you can have some guarantee in that first round that like, oh, this is the order things are going to land, right? And so hot stuff it's a modified Tendermint kind of flavor that allows this to be kind of pipelined. It separates the ordering problem from the consensus problem in the same way, actually the exact same principle that proof of history does for Solana, right? Proof of history says you're guaranteed that transactions like were timestamped in this order, so you can then come to consensus like in parallel of like the blocks actually being arranged. Tendermint and hot stuff is kind of doing the same thing. And what ends up happening is you can like, even though it's multiple rounds, you can end up stacking them. So like while some of the nodes on one block are coming to like ordering consensus in another thread in the same computer, like on the previous block, they're actually saying, okay, we're confirming it, right? And so you end up having this like pipeline of stages, and where you can like kind of decouple the act of saying this is the right order from we all agree on that order, or that it's a valid execution, essentially. Consensus algorithms, right? This is the main way like we've seen EVM chains scale. Like a lot of them just like fork Geth and just like build another consensus algorithm, right? And then essentially, oh great, now we're much faster in coming to agreement. Like the state of consensus research is continually evolving. Like why don't we use that research and essentially build something faster, right? There are very few teams that are tackling all three of those, right? Solana's like one of them, right? But they take this very opinionated stance about like, hey, we don't like the execution layer, we're going to do something different. And then like, yeah, like Monad is kind of taking this opinion of like, we can optimize all of this stuff, and we don't have to just optimize the execution layer to, essentially get the modern day benefits of like current Ethereum research. Like where you fall on this, and I kind of want to touch on this, so I'm going to take a tangent here a little bit, is like safety versus liveness. Okay. And I think this is something Solana gets a lot of shit for, is that like, oh, Solana goes down, right? And it's like, well, if the safety is the security of the chain is guaranteeing that there's the most survivable copies of the same thing, right? And so if you think about a chain that's like really fast, that all of a sudden like diverges from consensus, like half the nodes think one thing, half the nodes think the other thing. If you let that go on, there's a possibility that, okay, this half then splits into halves again, right? And it just keeps forking. And where do you say, like, what's the canonical state? You get into the state of like, if I just let it run, like there's a very real possibility that all of a sudden all my like secure copies are corrupt and I don't know which one's true. And so you have to make this decision of like, no, we need to stop at a certain point and say, hey, at this point, humans need to get involved, or maybe a different protocol needs to come in. And I think Solana is working on actually implementing like an automated protocol to do this, to say, hey, validators, you all stopped here. What is your view of the world? Let's all sync on that and then restart from there.
The big difference there between something like Solana and something like Ethereum L1 is just that the state, the amount of transactions happening on Solana are so many more transactions happening on Solana. So there's so much more memory. Is that the point, which is being taken up by all of these forks?
Yes. And so another thing you have to realize is validators need to track all the forks. Okay. Because they're talking to all these other chains, even if like 33%'s off there and like the other 67%'s off here. Well, I guess at that point it'll converge, but like if maybe you had 50-50, right? Like the validator itself is still tracking all the changes on this side as well as all the changes on the other side. And so imagine if that happens again and again and again, you're essentially just blowing up memory that this validator has to like keep track of. Okay. There's like a very real point at which like validators just don't have enough memory, and then they crash, and then they could corrupt their own ledger. And then all of a sudden, like safety is a problem, you don't have canonical. And so you have to make this very opinionated choice of like, that's too high of a risk. These are like very, it's better to halt and make sure everything is consistent than to just let it go on and like essentially maybe end up in problems where you have corrupted ledger states and then we don't know what the canonical chain is. Now, Ethereum makes like the decision, because it came from proof of work, it kind of had this benefit of like having probabilistic finality. So like even like we saw in the Ethereum incident, the deterministic finality kind of failed and like knocked over because like one of the clients was misbehaving or something, right? And what we saw is like probabilistic finality kept going. Okay. And so you couldn't say it was finalized, but you had like pretty good guarantees that what the chain had agreed on was going to eventually get finalized. And there's kind of two things that enable this. It's like, one, it's just lower block times, like the risk of memory running out on forks is just much lower. And then two, they have mempools. So like mempools are great in the fact that they save your ass if something goes wrong. Because all of a sudden you have like a buffer in front of everything. And so like, whereas Solana, like there is no buffer, as things come in, they either make it or they don't. and that is really nice for UX because you don't get this problem of like, oh, it's in the mempool. When is it going to land? Can I send a new transaction? Right. But it's also like from like a high throughput angle, it kind of forces the issue of choosing safety because you can't just have like too much stuff building up. Like you need to come to essentially agreement on what the canonical state is before you can start ingesting more transactions. Now, one thing we saw with Ethereum is like that multi-client architecture like really saved them, and like I think that's the thesis behind FireDancer is you have multiple clients, and so if one of them falls over, you still have the possibility that the other one is still going. And the way FireDancer is designing their like ingestion, so they don't have a mempool, so they have to take this approach of like we literally have to support the maximum amount of transactions that like the wire coming into my physical server can send me. So FireDancer is taking this approach of like, you couldn't send enough bytes through this wire to knock me over if you tried. Whereas like a lot of other chains are like, no, we'll put a mempool there and then we'll like deal with it as it's buffering. So I think that's kind of like the philosophical decision there. I think like the reality is it has to be somewhere in between, right? There's like UX implications for either one of them. It really just comes down to like a philosophical decision of like, what do you need as an application? And like, what do you think is like the most successful way to build a blockchain, right? And like, I think like kind of like to go back to the main point of this discussion is like, all these things have very nuanced implications. And if people aren't like willing to have conversations about what they mean, it really like makes the whole blockchain discussion very myopic and kind of like shrinks the space into like what even people think can be done on blockchains because they're like, oh, they work this one way.
Yeah. So actually, before we kind of proceed on, I want to do a quick kind of sidebar to help our listeners out because we talked about chains like Solana as well as other quote unquote EVM chains or EVM equivalent chains. Maybe like help us understand what does that actually mean from the developer standpoint, the user standpoint, and what properties are quote unquote EVM chains inheriting from ETH and which ones are they not inheriting? Like, how do we think about that?
And actually, maybe this is like a great segue into what execution is. Because when we're talking about EVM versus SVM, like essentially we're talking about the operating system. Okay. So EVM chains, like the only thing that defines an EVM chain is that if I were to take my code and put it into another virtual machine, like Ethereum virtual machine, it's going to understand it the same way. Whereas if you took that code and put it into SVM, it's going to say like, I don't know what these words mean. So EVM is just this definition of like, okay, if I take my code and put it on any EVM chain, it's going to understand kind of what I was talking about from the beginning, right?
Kind of a quick follow-up on that. Does that mean for just users or developers, either like it's easier for a developer to write applications on an EVM chain because the code is the same, or are there implications for applications that want to bridge? Like, how do we think about that?
Yeah, so this is like, it kind of depends. Like a lot of EVM chains are not like fully EVM compatible, and so you might have to make minor changes to your like application to get it to work. But the set of changes you would have to make is like much smaller than an SVM. Like, so SVM takes like, it's a completely different computer system. And I think like a lot of people and this is actually like what brought me into blockchains is that like the reason I never wanted to work on cloud before is it wasn't constrained enough. Right? You have this like environment of like just a computer and you can do whatever you want, right? Whereas in like the reason blockchains attracted me from hardware is because like fundamentally you can't code a smart contract without understanding how these things work underneath, right? And so Solana takes this opinion that every piece of memory should just be an account. And you can have a program, but the data that program, the state that program acts on is also another account. Okay. And what this enables is that like, if I build a program, anyone else can use that program and put in different data. Right. And so this is a two-sided sword. It's great in composability, but it's also like not great for distribution. And I'll get into that in a little bit. Whereas the EVM makes this like opinion, and so does CosmWasm actually, that state and data should be coupled. And so when you have a program on the EVM, and you call it, not only does it know the steps of what to do, but it has memory about like what was there before. Whereas on Solana, it knows the steps to do, but you have to tell it, where is my memory? How do I go recall things, right? And so you can have it recall different things. Whereas on like the EVM, you literally have to like make a new contract and deploy it, right? If you want it to have different memory. It's good and bad in ways. The big problem that we're seeing on Solana now is that like it essentially it breaks interfaces, and so everyone can define now, like, because there's no uniform, you don't know what's coming in, right? Anyone can pass any arbitrary data into this program. You also don't have, like, as a developer, if I want to call this contract, like, I have to know what that contract expects, right? There's not just like some shared standard that I'm like, okay, it takes like a deposit function, it takes like a withdrawal function for all of these type of, there's not even a word for it, but like, let's call it like a SVM20 token, right? Like that doesn't exist. Whereas on the EVM, there's this like, the ERC, right? Like the ERC standard is essentially, it allows like the entire ecosystem to agree on like, if I want a token, I'm going to have these function calls, and you don't have to understand what data I need to pass into those function calls. I just know that if I call them, they'll do like what they say. And so like how this manifests like physically is kind of this problem of like Metaplex owns the Solana NFT standard now. And like if anyone wants to make a new Solana NFT standard, all the dApps have to agree, okay, I'm going to like understand how to interact with your contact and integrate with it, which poses this really big distribution problem, because then you're like all of a sudden having to go to like all the wallets, all the marketplaces, and be like, please support my standard, right? On Ethereum, you have this model where it allows, like, if you support ERC20, I can make any variation of an ERC20 contract and like have certain guarantees about like, oh, your marketplace is going to understand how to interact with me. There's like good and bads to this, and I think Solana is actually like currently trying to fix this. It's like literally the interfaces problem. There's been Twitter Spaces on it. It's like an ongoing discussion within Solana to like come up with a standard to fix this.
Yeah, because it sounds worse to a layman.
Yeah, it
does
sounds
sound
worse than it is. Yeah, but it's like fundamentally this is just a computer science problem, right? Like it's not that hard to solve. I think Solana took the opinion that like ERC20 is not baked into the protocol, right? It's a standard built on top, right? And it's kind of taking this opinion in the same stance as like, this isn't important enough to enshrine into the protocol. Like the social layer should come to consensus on what this should look like. And Solana, just being the newer chain, I think is just like in that phase of like figuring that out right now.
Is the reason why Solana is architected like that to accomplish its goals of like parallelization of execution by separating out the data?
Yes, yeah. So there's two things. You get essentially native account abstraction now, because you like everything is an account. Just like what account abstraction brings to Ethereum is everything's a smart contract, right? Well, in Solana, everything's already an account. And so you can have a program on an account, which is called like a PDA, a program derived account. And that essentially is like makes account abstraction. That's like what account abstraction is, right? It's like now all of my smart contract can own another smart contract, right? And that's exactly what account abstraction is in Ethereum. There's slight differences in Solana in the sense that like there's like, because Solana is trying to be so performant, there has to be like restrictions on how big accounts and transactions can be, because they're solving this real-time problem every time you submit of like who touches what and how can I arrange it, right? And if the size of what they're arranging is always changing, it's like much harder to make an algorithm for it. If they know like the max amount of data I'm going to have is this, then you can actually come up with a very, very efficient algorithm to like arrange things, right? And so separating state and data like allows you to essentially like parallelize the execution, because you can do this like upfront analysis of like what data are you touching, right? What state are you touching? And if it's the same, then we'll run it in serial. And if it's not, then we can run it in parallel, right? This is kind of possible on Ethereum, just like the EVM doesn't do it. like the simplest way to do this, and actually currently how Solana does it, is like you just spin up multiple VMs, you know? And so each core in your computer is literally running a different instance of Solana's operating system, right? And as they look, when transactions come in, they go, okay, which one of these touch the same state? We'll run that all on one thread, and then run the other ones on another thread, run the other ones on another thread. That's something you can do on Ethereum, right? They don't specify state and data up front, but that also almost makes it easier because you know, like, oh, okay, like all my state and data is together right here. So two people calling the same thing, it has to be serialized, right? And so it's kind of the same problem. It's more about like an interface and like how devs like interface with it. And I think like the current way the Ethereum virtual machine is designed is like not to split that up, but like the easiest, most direct path to like making a valid, like an EVM parallel would just be, well, computers have multiple threads nowadays. Let's run up multiple EVMs.
I mean, that's always been a criticism of Ethereum, is that it's single threaded, but you're saying it is theoretically possible for that to change.
Yes, I think you can go farther in the optimization with Solana, and that's what program Runtime V2 is about. It's like on their roadmap. Essentially, it like, and this is getting really technical, so maybe pause me if it gets too detailed. But like the instructions that the actual like operating system understands, like essentially has extra information that will allow it to like not have to be in a separate VM. And so the VM can understand what touches what. And so like, yeah, you could run multiple of them, but a single VM can also just take advantage of like hardware level parallelization and like act on it. Which just means like less memory overhead in like the parallelization size, because you don't have to spin up like completely separate environments. You can have like one environment that has a very strict idea of what belongs where, and then operates like that. And this is actually the same like principle that like move chains are taking. This is like the paradigm Move is built on. And so like when Solana implements program runtime v2, it's like they bring that paradigm to support the Move language, but they also get that paradigm on every other language. Now, like when you write the language, the compiler may not enforce those rules, but it's technically possible. And so Ethereum, like as I found out recently, actually has the ability for you to specify like access lists. Okay. And so there's like this ambitious problem that like, can we then, okay, now we know what data and state you're trying to touch. Besides just running all this stuff in parallel VMs, can we maybe like try to squash those parts of the VM that are common together and then run them in parallel? And I think that's just like a problem not many teams are solving on the EVM right now.
I think it doesn't really get enough notoriety, if you like, the runtime v2, but it sounds big. It sounds big. So effectively, if I understand it right, this means that then you could use Move, the programming language, and use that basically on Solana. And then there'll be this compiler, and the Move language will go in and it will spit out maybe Rust on the back end and sort of operate just as Rust would really on Solana. Am I understanding that correct? And likewise, you could do that with other.
Yeah, I mean it's not Rust. It's like what you're saying is correct, but it's I think I call it a terrible name choice, SBF, but Solana bytecode format.
Amazing.
But essentially, that bytecode format is the same thing as like the Ethereum bytecode format, right? And so yeah, they're kind of essentially making that bytecode format more flexible. What it does though is actually like kind of bring it. That same interface problem I was talking about, like Solana and Ethereum, it ends up solving that. Because when your VM understands like that everything is like kind of a segmented object, essentially, it kind of brings like an object-oriented nature to like assets on chain. It essentially allows you to like have like arbitrary function calls. Like right now, like the way programs work on Solana is like, you know, I kind of have to know the interface and then I can call into it and then it'll go and I pass it some data and it does something. What Move does is kind of make all those entry points very generic, okay? In the same way that like ERC standards kind of do it. I mean, it's not completely analogous, but like from a user perspective, it's kind of, that's what you're going to feel, you know? And so it kind of removes a lot of the current developer bottlenecks for Solana right now. And it's almost like both VMs are, you know, attacking this from the same direction, you know, or sorry, from like adjacent directions coming at the same problem, right? It's like Ethereum already has kind of like the interfaces and composability side figured out in the way that its virtual machine is designed, but it never quite figured out like the parallelization and optimization portion. Solana like figured out the parallel and optimization portion, and like is now kind of going through this like, how do we change our VM to be more like composable and kind of permissionless? And I think, you know, Monad's taking this opinion of like, hey, we can go a lot farther on like how fast we can make this actual execution side and parallel side, because we have the benefit of already having like the composability and interfaces figured out. And that's kind of like, this is actually why I joined, because I think it's like a very exciting effort.
How would you kind of describe for some listeners that are less familiar with Monad the differences between like Monad versus ETH versus Solana on like a spectrum, even if that makes sense?
It's kind of like a middle ground. I would say it's like very much taking this like, we can do things like Solana, but we can do them with the prevailing like kind of programming language, Ethereum. And yeah, maybe we'll never get to like 300, 500,000 TPS, but we can realistically get to levels that are far beyond what current blockchains are using, right? And like they're like, when you get to a certain level, it's like, okay, that's probably good enough, you know, for certain applications. And so it's like, yeah, Ethereum, like Solana may be the fastest chain out there, and that'll be necessary for certain use cases. But Monad's kind of saying like, the EVM it's the one thing that kind of has like product market fit right now. And so like, why don't we just actually take this like engineering and innovation driven approach to like making it something that can compete with something like Solana, and essentially like bringing that kind of like world-class UX that Solana is known for to the EVM, because like the EVM is something like JavaScript where like everyone knows it's crap, but everyone uses it because it's the most optimized thing out there, right? And like, what did Google do? They went and created like a very fast version of it because they knew that if they tried to change like everything, no one would use it. And so it's kind of that same thing. It's like, okay, like if I was the most ideological engineer, like, yeah, maybe I'd go build it like Solana's doing it or Firedancer's doing it. But the reality of like what currently has product market fit, it's like you can actually juice that to a level that like kind of like what Google did with JavaScript to like make it fast enough to where, yeah, it'll just be used everywhere. And so it fits this like nice middle ground. It's also taking this stance that like, which I got into blockchains through Ethereum, so I'm kind of like a like decentralization maxi, although like I'm like practical decentralization maxi from my background in hardware. So it's like, look, running on a Raspberry Pi is never going to happen, right? Like, that's just like impractical to say that like the nodes need to be that small, right? But like, I don't think it's impractical to say like running on a like a MacBook M2, right? Sure, it's an expensive laptop, but it's not $200 a month server costs, right? And so it's like taking this middle ground of like, yeah, everyone can run a node. No, it's not cheap. You know, like for like people in like India, yeah, it's going to be expensive, right? But it's cheap enough that like the network economics should pay it back a lot more sustainably, right? And I think that's like another thing Solana is going through right now. It's artificially set its fee very low, and like this is like currently like a discussion. Like when I was at Solana, I was actually kind of driving this discussion a little bit about fee changes, because like fundamentally, like Solana is going to have to make fee changes, right, in order to be long-term sustainable. And like what those look like is just like a huge conversation with in the community. Now, I think you can arguably say that like fee changes are kind of like the easiest thing to make. Like technological changes are way harder, but it's a much more like social problem, right? And so it's like, you know, Solana's taking this opinion of like, we need users first, then we'll figure out fees, right? And they have so long to do that before like the network economics essentially become unsustainable, because like Solana actually does tail off. Like the the reward rates go down every year by 1.5%. So there's this ticking time bomb on Solana of like, okay, eventually we need to figure out, like exactly what we're going to charge for different state access and have opinions about like what costs more. Should it cost more to read? Should it cost more to write? Should it cost more to like lock accounts? But these are like active conversations. If you go and read like Solana Indies, this is like very active development conversations that are going on. So the one thing that kind of like reassures me about Solana is that like they are thinking about these things and they're attacking them. The benefit with like EVM chains is like there's already kind of a model to go off of. Now, I think Ethereum takes a little too much of an opinionated stance on like where that cost should be. Whereas like Monad's kind of in the middle there where it's like, no, we need to be cheap, but we need to be like practically cheap. Like yes, hundredths of a cent transaction, but maybe not millionth of a cent transaction. And for a typical user, that doesn't matter much. And like when Solana does full optimizations, it might be 100th of a cent anyways.
Your discussion on Monad, it sort of comes back to what we were saying at the very beginning about it's about trade-offs. And as you said, probably Monad is never going to be quite as performant as something like Solana, but it inherits the EVM. And to me, it seems a more, sensible approach to scaling probably on Ethereum compared to the current more modularized approach where they're sort of leaving the Ethereum L1 alone and then they're trying to scale through the layer 2s. Yeah, and it seems more sensible to me to actually try and transform and change that layer 1, the actual execution layer. So I suppose just leading on to that, it'd be really interesting to get your view on this debate between modular versus monolithic architectures and, how you see the likes of Solana, Monad, and Ethereum.
So you can kind of like bucket this into two kind of like prevailing views, and the modular thesis looks at it as kind of the way like current cloud infrastructure is going to evolve, and the monolithic view kind of looks at it as the way like current hardware infrastructure evolved. And what this means is like from a modular standpoint, right? If you think about like current web infrastructure, it's like there are a few main like service providers like GCP, AWS, Azure. When you go onto their sites in your company and you're like, okay, like I need a database solution, but I need a database that does these particular things. And they have some product catalog that you can like pick all these like components off the shelf and they'll like put this server construction together for you and serve it up for you. And then there's like very smaller, niche service providers that do this for like very, like specific, Web 2 companies. I think like Snapchat had like their own partner that like did all their infrastructure for them. Okay. And so this is like kind of how we see like these modular stacks developing. You see like OP building OP stack, Starkware doing like, it's like Starkware stuff, and it's kind of like they're marketing like, hey, like come, we're this like cloud platform provider and we have all these things you can put together and like build a a blockchain out of me. I'm going to stop there. I have opinions on that because like fundamentally it feels like you're rebuilding Web 2, right? Like you're just rebuilding silos, and like, yes, maybe these stacks can work together, but there's still a lot of stacks. It's like maybe all the AWS people can work together, but it's not going to work between AWS and GCP, and so it's like, okay, do we really want to go down that path, right? I think that's more of like an ideological decision. We know that path is product market fit, but like wasn't the purpose of blockchains composability and like, bringing these promises of like crypto economics, right? And so the monolithic thesis is kind of on the other side of that. It's looking at like, okay, how did performance systems come about today? Like when we really look at like what juiced performance, like what was the main principle that did that? And what you find is like really common between all these high performance systems is co-location. It's like the fundamental thing. It's like if you put things close together and have less communication overhead, less synchronization overhead, less like trust assumptions, you can just like build systems faster by assuming certain things. Because there's like less communication in between that you have to handshake and make sure like, are you doing the right thing? And so like this is played out very tangibly in like the computer chip market. Like if you noticed like, Intel Inside was like the biggest thing for the longest time, like Core 2 Duo, yeah, like Intel Inside and like, have all these like discrete components that Intel was like, we're going to like make the best graphics card. We're going to make the best processor. And then you can just like put them all together in your own computer and it's going to be a fast computer. And a lot of people bought into that for a long time. And that's like essentially how the computer market developed. And we saw, kind of the performance of like computers kind of, logarithmically taper off. They like weren't really going that much faster. And it was like, okay, like, well, what's the bottleneck? It turns out like communicating between all these chips was the bottleneck. So what did Apple do? It goes, we're going to integrate all these onto a single die. They slap the M1 and the M series table like on the table, and instantly you get a 10x improvement in performance, like something we'd never seen in like computer chips in almost a decade. And it was just like, wow, okay, co-location matters, and then you kind of see this in like in high performance cloud systems that use something called like edge compute, which means like push everything down to the local device and have it do a lot of the work, right? And the fundamental principle behind that is co-location, for like gamings and stuff. Like they just send, like they rely on that server, the local thing, like actually rendering this stuff and doing it quickly because they can't do that up in the cloud and then send it down. And so you end up seeing that like if you want performance, you need co-location. At the same time, like the way current markets have developed, there's like a very strong kind of product market fit for the current way like current cloud computing systems are architected. And so like in reality, like I think it's gonna, and I think like most blockchains are converging on this kind of hybrid, right? Ethereum's like taking this very opinionated stance, like everything should be modular, and that has like very deep implications I think I want to get into after this. Whereas like Solana is saying like, okay, if you want to integrate with us, like as a DA layer, like you have to conform to how Solana does things. We're not just going to like provide you like a generic interface, right? And that's kind of the difference is like when you go to generic interfaces and say anyone can plug into me, you can't make assumptions about like data formats and communications that allow you to speed up. It's like you have to check those assumptions every time. And so like it's kind of like what's going to win out, probably something in between, like probably something with like enshrined components of some sort, like you have to conform to this construction of an L2 in order to plug into us, but we'll let you plug in and then you'll get the performance because we can make assumptions about like how data flows between these things.
I mean, maybe you're going to touch upon it, but it'd be interesting to get your view. You said Solana is going in this way. Are you talking about layer twos, like uniform layer twos being built on Solana? Is that the direction it's going? Or are you talking about compressed accounts? Just wondering.
It's more of this idea of like we can split up certain parts of Solana. So like a very recent, it's equivalent of a EIP on Solana. Yeah, that Anatoly just put out is asynchronous block production, and you can kind of think about it. It's not the exact same, but it's like proposer builder separation on Ethereum. Realizing that like builders are like highly incentivized to like extract MEV and run big machines to like find the best ordering to get a lot of value out of it, and validators like are not incentivized to do that, right? They just want to like validate and collect their rewards, right? And so if you can split these two things up, like the incentive systems kind of work better. But beyond that, like it also just like kind of allows each piece to work like very quickly, together, like they do what they do best, right? And so that's kind of the thesis between monolithic chains is like, okay, well, everything's going to do its best. The difference with Solana is it's making a very opinionated stance about how these two things connect. In a modular chain, you're saying like, oh, you just like generally conform to something and we'll like make sure it goes together. Solana is saying like, no, we will separate these, but we're very opinionated about like how you communicate between the two because that equals speed. And so like, I think, all these ecosystems are generally heading this way. They're kind of like, I think the prevailing view at this point is like, if you want performance, you're going to have like heavy builders or like, some part of the block building process. But you can still give security guarantees very cheaply to users through things like diet clients and light clients, which is like much more practical. It's like when I want to interact with the chain, I have trustless guarantees that those things are acting correctly, but the actual node operators are incentivized to run big things to extract value and stuff like that.
It comes back to Vitalik's quite famous Endgame blog post that he put out, I think fairly recently, where basically, monolithic chains like Solana and modular chains like Ethereum are eventually going to converge on the same end place of centralized block production, but decentralized verification, basically. And they're both getting there in different ways.
And I think like the very nuance there, the nuance between these two approaches is taking opinionated stances on how these modular pieces talk to each other. In a modular chain, you're taking like a very open approach to that. You're saying anything can plug in. In a monolithic chain, you're saying like, no, you must conform to this way of talking to me. And because of that, I can give you very good performance guarantees. I think like what a lot of people miss is like modular is inherently saying that if I want to get adoption, I better be the best at the piece of what I'm doing, right? Because if you have 100 DA layers, 100 execution layers, and 100 consensus layers, right? In a modular ecosystem, you're taking the bet, I am the best at one of those things, and I'm going to be pulled off the stack when people go like to this, stack to shop for what I want to do to build a blockchain. Like, I'm going to be the best at one of these things, right? I think it makes a lot of sense for things like Celestia, where they're very much taking that first principles approach. They're like, we are the best DA layer, or Eigenlayer is saying, we are the best DA layer. And then like, execution like Fuel is like saying, we're the best execution layer. And, Move chains are saying, we're the best execution layer. Solana is saying, we're the best execution layer with the SVM. The thing is, like, it's clear that if the EVM is not the best execution layer, right? It has product market fit. So like that's another argument like in its favor, but it's clear it's not the best execution layer. It's also clear it's not the best DA layer because we wouldn't have things like Eigenlayer and Celestia trying to solve these problems, right? What's not clear is that it's not the best consensus layer. Like Ethereum might actually be the best consensus layer. And that's where it gets complicated, right? If it's not, then like, what is Ethereum the best at? Why would it be used? If it is, it really validates some of their theses around like why the chain is used. Now, I think like where this gets kind of complicated is like the ETH community is actually the forefront of a lot of this research. And so like inherently they're kind of saying like we could make consensus better. Like Hot Stuff and Hot Stuff 2 are like kind of out of the EVM like landscape of building. And like the fact that they're like really, this is getting a lot of hype and like being used in a lot of chains is kind of coming to consensus that like, wait, this is the new best consensus layer, right? And so you're put in this weird position in a monolithic chain. It's like, if you're not the best, are you going to be used? And so what is Ethereum the best at? Having liquidity. And like, how much does that matter? Like all these L2s are kind of bets that like, oh, you'll move this liquidity to me. And then it really puts the value prop of Ethereum like in dire straits, right? And, you can make an argument for economic security. I just don't believe it. Because like if someone actually wants to hack a chain, they're going to send a bug in the code and steal all the stake. They're not going to try to buy it off the open market.
Yeah, we had a previous conversation with Lamar about economics of blockchains, and he talked on the sort of the commoditization of block space, that eventually this tribalistic, cheerleading of particular blockchains will go away, and it's, as you said, it's going to be a case of, okay, well, what's going to give me what I need, and that's not necessarily going to be Ethereum just because I've heard about it, and I'm a big fan of the movement. It's, it could well be, no, what's going to be cheapest, what's going to knock cents off my dollar of expenses, basically.
Yeah, and I think like the EVM has provided that moat, like as of now, because the EVM is product market fit, it provides that moat, right? But as soon as you get like a credible EVM that's better at all these things, like it really starts to, nip away at this like 10-year-old, 12-year-old technology. Like, fundamentally, like with the single threaded versus parallel, like just look at history. How many single threaded computers are still in existence today? Like I literally couldn't go and buy one if I tried. And that's where it's like, you gotta fix that at least, And then you get into like, okay, well, you can fix parallelism on, the execution side, but Ethereum has enshrined the EVM into data availability, which means the way it does data availability is with a single threaded execution layer. There's no separation there that Celestia makes. And so they're taking a very opinionated stance that your data availability will never need to be parallelized. So even if you can parallelize the execution, if you're not parallelizing the consensus by separating ordering from actual consensus, agreeing on what happened versus what order they happen in, which is kind of what Solana's proof of history is. It's also what Celestia is doing. It's what like Hot Stuff is able to do by having like parallelized kind of stacked pipelined, stages. You enter this like case where it's like, okay, your execution is parallel, but like to really get that performance, like you need to parallelize all the other parts. And Ethereum's taking this like very opinionated stance about saying, no, we're not going to do that.
That kind of brings me to a question I have that might start pulling a lot of these things we talked about together, which is, how do we best think about trade-offs between these different ecosystems? Like Ethereum seems like you're making a bet almost that consensus layer is super important, that they're doing it the best. Maybe SVM, like Solana, you're kind of betting that their approach to execution will win out in the long run because it's so scalable. And then even like quote unquote monolithic EVM chains, and then you have the whole modular ecosystem with rollups. Like, how do you think about the trade-offs all of these players are making and what they're prioritizing?
Really, like tangibly, it's just going to come down to where the killer use cases are built. When you find a stack that can support that killer use case, it's going to get all the adoption, right? And so like right now we can say that the majority of apps are built on an EVM. And so like EVM is product market fit, right? And therefore it's clear that like maybe we should pursue the EVM, right? But like the minute there's an SVM app that's like amazing and brings in more users than all of crypto had, like then maybe the SVM gets adoption, right? And like while we can sit here like in today's day and age with like very little blockchain adoption relatively to Web2 apps, you can kind of theorize about like what standard is going to win out, but I think like it's really going to be the standard that supports the apps that everyone wants to use, right? And all these companies are going around and making different trade-offs saying like, we think this construction is going to support that app that everyone's going to want to use. And I think you have to think about most blockchains besides like Bitcoin essentially as like tech startups. It's like not helpful to think of them as currencies. Like Bitcoin, all it does is store value. It like makes sense as digital gold. But these other ecosystems, fundamentally they're all like tech startups, and they're saying our construction we think will support this ecosystem the best. And I think you just have to evaluate about like what can be built on this tech stack. Do I believe that's the thing that's going to take us from that like zero adoption to one adoption, like that 0 to 1 moment in adoption? And most likely that's going to be the stack that wins out, to be quite honest, because people follow users fundamentally.
Right. Maybe a kind of asking it in the inverse is, what can we do on a chain like Solana or a chain like Monad that we can't do on an L2 like Arbitrum or Optimism today?
Yeah, I think that just comes back to like scale, really. Is like I think there are ways to do most of this stuff. Only possible on Solana is mainly only possible because Solana is the only one with scale, right? But like the minute you start getting EVM chains that are reaching like 400 actual TPS, Solana has a lot of votes, and there's very like we can go into why. That's actually like a pretty important point to make. But like the actual transactions is somewhere around like 400 or 500 a second.
The normalized TPS.
Yeah, is like 400, 500 TPS. So once you start getting EVM up to that range, which is very possible, it starts being like, okay, what's only possible? Then you have to start differentiating on like, okay, what is state separated from data enable that like just raw scale doesn't? I think compressed NFTs are one of those. There's like a very, like, it's hard to do compressed NFTs when state and data are together. It's not an unsolvable problem though. And so it's like, okay, like first, I think EVM has to get to the point where like the only possible on Solana meme is put at question just purely because like, oh, it's actually fast enough, right? And then you get into questions of like, okay, what value props does move bring? Does, the state versus data, being separate bring? And then you have to start comparing on other things. I think right now we're very much in this stage of like, we just need raw scale. Like most apps, like Helium's running on Solana, it's still only 500 TPS. And so like that tells you something about like how much actual usage is on Helium. Like it's great. I think it's like one of the most bullish use cases of crypto because it's so tangibly there. But fundamentally, like the next chain to get 500 TPS, like real TPS, could theoretically steal that away pretty easily. Local fee markets are a big innovation. But when you get into like parallelism, that kind of falls out from it pretty easily. And so like you can start having local fee markets on an EVM if you start having, like parallelized EVMs and stuff. And so it's like, okay, what's going to be the moat? Like, quite frankly, like probably user adoption and use cases. I think Solana has a very credible path to be like the highest performing TPS chain. But from like a user adoption perspective, like an EVM with, even like if Solana is running at 100,000 TPS and like, well, you have to say how many of those are votes, but, say we have 100,000 real transactions a second, right? And an EVM has 10,000 real transactions per second. Is that a differentiator, right? If we're only using 500 right now, is that a differentiator? Because you have so much headroom anyways. It's kind of a bet on like what's going to support bigger adoption. I think one thing monolithic chains have really going for them is cultural. Is that like, it's a lot easier to have a shared vision of an ecosystem and a culture and composability when everything's on one chain. I think that's like what a lot of people underestimated about Solana is just how that community is so fervent because they're like, you're on one ecosystem all the time. It's not splitting up into L2 saying one's going to be bigger than the other. It's let's all work together to make this thing succeed. And I think like monolithic chains, I think that's what built the strength of ETH originally. It's what built the strength of Bitcoin originally is you need that kind of evangelist community that's not constantly looking over their shoulders going like, could that be a little better?
I agree with you on a lot of those points. And it's hard to predict actually where we're going to go with all this, given all the camps that are out there, so to speak. I think what's clear is that base layer ETH is not usable for most people. And so that's why we have L2s. That's why we have all these monolithic L1s that are EVM compatible. Some aren't. But yeah, it will come down to, I guess, what can scale to everybody. And it's still, I think, an open question that's unresolved.
I think one final point I'd like to make, if I could, because I did touch on it a little bit, is kind of like why Solana has so many votes. Because it's something Solana gets a lot of flack for, and I think it's like worth talking about it because it actually has very deep implications for decentralization. Fundamentally, all blockchains need to do this task of like, it's called block propagation, and that means like, okay, if I'm a builder and I say like, this is like, it's my turn to like say, this is the block that's going to go to the chain. Like, how do I tell that to everyone and how do I do that quickly? Right. If you have 400 millisecond slot times, it means that like, everyone needs to get that in 400 milliseconds. And if you have thousands of nodes, that's like really hard, right? You're like trying to send this to thousands of nodes like as quickly as possible. And then beyond that, they have to like reconstruction and execute it and do all that, all within 400 milliseconds, right? And so Solana designed this thing called Turbine, right? Because they needed to get that data to all these other nodes like as fast as possible, okay? Well, it turns out that like a vote is the same thing. Like even if you send it on some other network, right? Even like a gossip network, the same way to optimize block production is the same way to optimize like any gossip network. And so it's like, okay, well, if we already built like the fastest block propagation protocol, like we should just actually put votes in there too, because what that means is like now you're like how many nodes you can have is not bottlenecked by like this other algorithm. Like you only have one algorithm to worry about, right? And so for a lot of these like other chains, like even though votes aren't in the blocks, right? The validators still need to communicate with each other, these votes. And how they get that data is still the same problem as how they get transaction data, right? Now, if your block times are longer or you're a slower chain, it's like, it doesn't matter. You can have like the gossip protocol be faster, right? But if you're getting up to like thousands of nodes, like Tendermint chains don't need this because there's typically you can only scale up to like 100 nodes, you know? And so like gossip is fast enough with 100 nodes to make the UX experience of like actual transactions pretty nice. When you're reaching Solana levels, you know, it's like, okay, do we design 2 protocols to do this? Or do we just optimize the crap out of one and then send the votes down there, right? And so you do have like a lot of votes there, but like it's actually good because the more TPS you can support, it means the more validators you can support. And so Solana TPS isn't just a question of like how many, maybe it's only 400 or 500 actual transactions. All that other headroom is like what enables there to be 2,000 nodes on the network syncing at the speed of light around the globe, right? And like as you get into scale, that becomes like a much bigger problem. And like it's kind of the reason Monad's like not choosing to be an L2, right? Like at some point you have to do like a tree topology for block propagation. And then there's like all sorts of other clever things you can do, like not send the full block, you know, like hashes and stuff like that, to essentially like make the amount of data you're broadcasting like much less. And yeah, these end up like when you get to scale, like Solana's dealing with a lot of these problems that every chain that is going to scale to that level is going to have to eventually deal with. And so like these monolithic ecosystems are kind of like tackling that first. I think the modular ecosystems are tackling this like kind of product market fit of like server side, you know, kind of stuff. Like rather than dApps, like, okay, if I'm taking a view of a cloud developer and I'm trying to like build a lot of blockchains everywhere, like they're taking this view of like, okay, well, we need to build, you know, things that would make that very easy. And I think like monolithic chains are more of this perspective of like, well, that's great. They'll figure that out and we can always add that. But like fundamentally, we just like actually need to make this thing fast so we can run actual products on it.
That makes sense. I think it's a great overview. And you know, obviously throughout this conversation, we touched on a lot of different topics, but really appreciate you bringing your engineering expertise to help us demystify the differences between all of these blockchain ecosystems.
I think it's just like really important as people think about these systems to not get sucked into these like tribal, this is best, that is best, right? Like if this industry as a whole wants to scale, like there needs to be conversations about all these things in order to like enable new use cases. Like, you know, especially with like AI and the advent of all these things, if we want these like new use cases to proliferate, then we can't be kind of myopic about our views of blockchains. We have to like expand that to understand, you know, what are the different trade-offs, what applications would be good on these blockchains, and like, do I believe in that thesis?
Some great words to close on. Thanks again for joining us, Kevin.
It was great.